on this one. Let's write it down. What's the simplified form for this one? The simplified form for this one looks like it's negative 2 times what? Over what? X minus 4. So this one is coming from 4. F is 4 from the what side? 4 from what side for F? 4 from the right. So 4 from the right. So X is going, so we're doing the limit as X goes to 4 from the right. That means 4 from the right is greater than 4 or less than 4? Which one is it? Is it greater than 4 or less than 4? Greater than 4, exactly. So if something is greater than 4 and you subtract 4 from it, the bottom is going to be positive or negative? It's going to be something really small, but what? Positive. And on the top, what does the top go to? If X is getting infinitely close to 4, what does this get infinitely close to? Well, what's 4 plus 2? 6. What's 6 times negative 2? So this gets infinitely close to negative 12, and the bottom gets infinitely small and positive. What's negative 12 divided by an infinitely small positive number? Negative what? Negative infinity, exactly. If you have something like 12 divided by something small is going to keep on getting bigger. Like when we say small, we mean as small as you want. So like, what's 12 divided by 0.00000000001? Well, it's big. But what's in front right here? So it's going to be negative. Now, if you go from 4 from the left, what's the only thing that changes?
The sign.
The sign. So instead of a small positive number, it's going to be a small what? Negative number. It's going to be a small negative number. And then you have a negative over negative, so instead of negative infinity, it's going to be positive infinity. Positive infinity. Size is completely relative. Like we think of 12 as like, oh, 12's not that big, right? Well, 12 can be infinitely bigger than many things, right? Or a lot bigger than many things. Because one is odd, you know it's either going to go down and up or up and down. If it was an even number like x minus 4 squared, it's either both up or both down. There was one on the homework last night that did that. You'll notice down here, which one was it? It was this one right here. Take a look at this one. What do you see twice there? You see x minus 1. So that's actually x minus 1 what? Squared. So that means that asymptote, which happens at x plus what? X plus 1 right here? It both has to go up or both has to go down. Okay, and in that case, it both goes down.
So it wouldn't matter if...
Look at this. You are approaching negative 3 from the right. Negative 3 from the right. What's a number to the right of negative 3? So get closer, yeah. So negative 3 from the right, it could be something like negative 2.9, right? Or what? Negative 2 point what? 99, negative 2.999. You're getting closer and closer from the right. So you take these numbers right here, you take these numbers and you think, well, when we plug them in up here, what is the top going to get really close to? Well, what's negative 3 plus 2? What?
Negative 3.
So the top gets really close to negative 1. But the bottom, so like think about this, negative 2.99999, right? When you add 3 to it, does it become positive or negative?
Positive.
It becomes positive. Is it going to be a big number or a small number?
Really small.
It's going to be exactly a really small positive number. What's negative 1 over a really small positive number? Yes. Remember, we think to ourselves, oh, negative 1 is small, but guess what's really, 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 really small? The denominator. Negative 1 divided by a small positive number is a negative infinity. What's the only thing that changes when you go from the other side? Instead of negative 2.999, it might be negative 3.001.
Yeah.
When you add 3, what changes here? What's the only thing that changes? It becomes a small negative number. It becomes a small negative number. Negative over negative is positive. One of them is infinitely small. One of them is a number. So it's going to be positive infinity. Does that make sense? You'd be like, no, pass. Okay. It's actually pretty straightforward. You have dealt with fractions before. Can someone give me a specific thing I can do first in order to attack that equation? Yes?
Find a common denominator.
Find a what?
Find a common denominator.
Finding a common denominator would be a great thing to do. Finding a common denominator would be a great thing to do. Could someone tell me what a common denominator could be on that one? There are infinitely many common denominators. What's one of them? What?
12x.
12x. Now, what are you going to do with 12x once you've found that common denominator? What are you going to do with it? Exactly. You're going to take this entire equation and multiply by the common denominator. Now, is that common denominator 12x over 1, or is it 1 over 12x? You said the common denominator is 12x. Is it 12x over 1, or is it 1 over 12x? We need to multiply by 12x over 1. We're going to do that because something very nice happens. When you multiply the equation by 12x, what happens to the first term? Who wants to tell me what happens to the first term? Okay. Everything in the equation by 12x. So that's going to be 12x times 1 over x. That's going to be 12x times 1 over 4. And that's going to be 12x times 1 over 6. You have to multiply everything by 12x. Everything by 12x. That's nice and helpful. Why? Can someone tell me what happens to the first term? Can someone tell me what happens to the first term?
12.
It becomes 12, yeah. Plus, what does the second term become? 3x. And what does it equal? 2x. What should I subtract from both sides?
-3x.
Well, I'm subtracting 3x, so adding negative 3x. It's fine. So 12 is going to equal what? Well, you're going to subtract 3x from both sides, and you end up with 12 is equal to negative x. We're not quite done yet. We're almost there. What does it become? X is negative 12. Now, the key to all of this was that Jen found the common denominator. Jen actually found a really nice common denominator. What common denominator did Jen actually find? She found a very specific one. Which one? She found the lowest common denominator, the least common denominator, the smallest common denominator. You could have done, for example, 24x. Some people probably would have done 24x. Why would they have done 24x?
4 times 6.
4 times 6 times x. If you can find the LCD, it'll lead you to the answer quickest. That being said, if you're having a hard time finding the LCD, which can be hard because factoring is hard, just go with the common denominator. And what's the easiest way to find the common denominator? Multiply all the denominators. What's the risk in multiplying all the denominators together? What's the risk? It could get big, right? Like, for example, a common denominator is 1,200x to the 15th, right? That technically that's a common denominator, right? But is that very helpful? Just say no. Just say no. Just say no. Okay. What about this one right here? Do this for me. Find a common denominator and write it down. Actually, the what denominator?
Lowest.
It is. It's the least, lowest. So we multiply everything by 15x. Can someone tell me what I get when I multiply by 15x? Can someone tell me? Connor, what do you get? What's 15x times 1 over x? X. Is that pretty nice? That's pretty nice. You should be like, hallelujah, that's really nice. You should feel happy, good things when you get something that clean and nice and straightforward. So you end up with 25 is equal to 3x. So x is equal to what? 25 thirds. Exactly. Now, if you have time, what should you do with these answers? Check them. Check them for me. See if they work. And how do you check them? Plug them in. Plug them in manually. X plus 20. And what do you have to do to this one first? Factor the denominator here. What does the denominator become when you factor that one? Right here. What's the denominator become when you factor it?
X times x minus 2.
Ah, so does that make it easier to find a common denominator? Yeah. What's the least common denominator on this one? Yes. X times x minus 2. What happens, boys and girls, when you look at this one right now? You can come back to that and fix it. When you multiply by the least common denominator, when you take this right here and multiply it by all three things, what happens? You end up with 3 times x minus 2 plus 6 times x equals 12. Is that about as nice as it gets? That is super nice. But here's the thing you need to realize. Keep going. 3x minus 6 plus 6x equals 12. 6x. So what do you end up with? 9x is equal to 18. You're like, yeah, x is equal to 2, and you're all super excited. What's the problem? And there was a big hint up there. What's the problem?
X can't equal 2.
Yeah, what's the domain of this function? X such that x can't equal 2. So this would be a extraneous solution. Another way to say that, I like calling them like false solutions. because it's not in the domain. Can you plug in 2 into that thing? No. So technically, are there any solutions to this equation? There are no